Hello guys, let's start with another problem which is known as find the pivot integer. So we have already solved these kinds of problem. What we are given with? We are given with an integer n which is positive and we have to find the positive integer x such that the sum of all the elements between 1 to x inclusively including 1 and x are equal to the sum of all the elements between x to n, that is also inclusive. Okay, we have to return the pivot integer. If no such integer exists, then we have to return -1. It is guaranteed that there will be at most one pivot index for the given input. Okay, so guys, we are given with an example. If n is equals to 8, okay, if integer n is equals to 8, then its pivot element is 6. How it's 6? As we can see, while we are adding 1 plus 2 plus 3 plus 4 plus 5 plus 6, we are getting 21. And if we are adding 6 plus 7 plus 8, we are also getting 21. Hence, pivot element is 6. That is, x is 6. Guys, how could we solve this problem in a most optimal manner? Think about it. Think about it. Randomly think about it. First, there is something which is known as two-pointer approach. Okay, I think before also, while solving the to find the pivot index of an array or some kind of these question, we have used this kind of approach only, right? Two-pointer approach, something like this. But what about if we can use something else here, something mathematical approach like arithmetic progression formulas or something like that? How can we deal with it? How? Think about it. Think about it, guys. I have a very smart solution for it. Very smart. Just think about it. The hint I have already given to you, that we can use arithmetic progression formula. What it could be? Guys, think in a manner. What if we calculate the total from 1 to n? How we'll calculate the total from 1 to n? Adding from 1 to n, that is 1 plus 2 plus 3 till n. What is the arithmetic progression formula to this? The arithmetic progression formula to this is, that is 1 plus 2 plus 3 plus 4 till n, it's n plus, n into n plus 1 divided by 2. We are getting the total. Now we want the pivot integer, that is the middle where the sum from 1 to x is equals to the sum from x to n, including 1 to x and x to n. What could be our approach, guys? What could be our approach? As soon as we calculate the total from 1 to n, our pivot integer becomes actually the our pivot integer becomes actually the square root of the total, or we can say total is equals to the square of pivot integer. Am I correct? Am I correct, guys? That means x square is equals to the total, and this is total. So if I'll calculate the total, that means if I need x, then math dot square root of total is equals to x. This is my logic. As simple as anything else. Both time and space complexity, both are constant, that is big O of 1. So let's solve this approach. What we'll do? First of all, we'll calculate the total. How? Using the arithmetic progression formula, that is n into n plus 1 divided by 2. Then to calculate x, what we'll do? We'll calculate method square root of total. And at last we'll check that if square of x, that is x into x, is equals to total or not. If it is equals to total, then we'll return x, otherwise we'll return minus 1. Because if x square is equals to total, that means x is the pivot integer of n. Otherwise, there is no such pivot integer present, as in case of 8, if n is equals to 8. Guys, if n is equals to 8, what would be our logic? What would be our logic? If n is equals to 8, that means if we put the formula of total, then it would be 8 into 8 plus 1 divided by 2. That is equals to 4 into 9, which is equals to 36. And if we calculate math dot square root of 36, that is equals to 6. Am I correct, guys? Am I correct, guys? Right? If we are assuming that 6 is the value of x, that is pivot integer, and I am multiplying 6 with its own value 6, we are getting 36. Hence 36 is equals to total. That means 6 is the pivot element. Correct, guys? So this is our logic. What we are doing? We are calculating the total using arithmetic progression formula, that is n into n plus 1 divided by 2. Then we are calculating x, that is pivot integer, as the square root of total is equals to x. Okay, so we are calculating the square root of total and representing it as x. Now we are checking whether x is the pivot integer or not. How we'll check? We'll calculate the square of x and check whether it is equals to total or not. If it is equals to total, then we'll return pivot integer as x. Otherwise, we'll return minus 1. Let's try to run it, guys. Let's try to run it. Oh, my bad. I have to do n into. Yeah, it is working absolutely fine for first case. For second case, as the value is 1 only, so it will return 1. For third case, 4, there is no pivot element, hence it is returning minus 1. If no pivot integer is present, then it is returning minus 1. Let's try to submit it, guys. Yeah, it is working absolutely fine. What about the time and space complexity? As we are already using some integer like total and x to represent the pivot element, hence the time and space complexity both are constant, that is big O of 1. That's it, guys. Bye bye. Please, 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 please try to solve the quiz at last. Please, it's a humble request. Bye, guys.